Okay, I had started recording day 3 and then I got interrupted, so a few of these are already done, but I want to go ahead and talk through them to make sure that you understand how to work each one of these. So we're on 66. The 66 is area of a parallelogram, which is just base times height, or in this case 3.7 times 7.6, which gives you 28.12 centimeters squared. And again, if you need to pause this, please do that. I'm going to keep going just to try to keep the video as short as possible. Okay? 67 is another parallelogram, so it's still just base times height. The base here is 36 and the height's 33. The product of 36 and 33 is 1188 inches squared. Remember, with area, the units are squared, okay? And 68 and 69 are both triangles. These are 1/2 times base times height. So on 68, half of the base, so the base is 10, half of 10 is 5, and times the height of 3 gives you 15 square yards, okay? So for number 69, we have 1/2 times that base of 4.4 times the height of 2. Well, if I'm going to simplify this, I would say, well, half of 2 is 1. So those basically become 1. So your answer is simply 4.4 centimeters squared. Okay? All right. So looking at 70. 70 wants the area of an equilateral triangle with a side of 10. So I'm going to sketch out an equilateral triangle here so I know what I'm looking at. In the equilateral triangle, each of the angles are 60 degrees. It says the sides are 10. So to find the area of any triangle, you need the base and the height. So I'm going to drop a height down here, which will split this equilateral triangle into two 30, 60, 90 triangles. In the 30, 60, 90 triangle, well, this altitude is going to split this base in half. So the short leg here is 5, which makes the long leg 5 root 3. That long leg is the height of this triangle. So to find the area of this triangle, I have 1/2 times the base of the triangle, the base is 10, times the height of the triangle, which is 5 root 3. Okay? So half of 10 is 5, and then 5 times 5 root 3 is simply 25 root 3. And this answer does want you to keep it in simplest radical form. So that is your final answer. Units squared because it is area. All right? 71, the area of a trapezoid, which is 1/2 times the height times the sum of the bases. So we're going to need to find a little bit of information here. We already know that the height is 9. That gives that to us. This is the height. Okay, one of the bases is 5. So this piece down here is also going to be 5. Okay, so this is base 1 is 5. We need base 2. So, although it doesn't look like it, and this is not drawn to scale, if this is a 45-degree angle and this is 90 degrees, then this is also 45. In a 45, 45, 90 triangle, the legs are always the same. So this piece is also going to be 9. So I have 9 plus 5 plus 2 for my second base. So I have 16 for my second base. So my bases are 5 and 16. Okay, so then I'm just simplifying here. I've got half of 9, which is 4.5. And I'm multiplying that times 5 plus 16, which is 21. So, I've got 4.5 times 21, which gives me 94.5 centimeters squared because we are still working with inches. Alright? Okay, so I have another trapezoid here in number 72 and 73. And on these, I am looking at special right triangles also. So I need to think about what else I need here. 1/2 times the height times the sum of the bases. And all I have is one of my bases here in number 72. Okay, I don't have my height yet. I only have one of my bases, so I need my other base. Okay? Alright, but this is a 60-degree angle, and this is 90, which makes that 30. So I can find the rest of this out because I know the properties of my 30, 60, 90 triangles. The hypotenuse is represented by 2x, the short leg by x, and the hypotenuse or the long leg by x root 3. So if the hypotenuse is 2x, then the short leg is 4. I'm sorry, if the hypotenuse is 8, then the short leg is 4, because the hypotenuse is always double the short leg. If the short leg is 4, then the long leg is 4 root 3. That's your height. So the height here is 4 root 3. So if I know that this piece is 4 and the whole thing is 18, then this piece must be 14, so my other base is 14. So now I have all my pieces in place. And I know I'm talking fast, but I also know that you have the ability to pause this and rewind it and watch it again. So feel free to do that. Alright, so I'm going to simplify this. 18 plus 14 is 10, 20, 32. and half of 32 is 16, so I've got 16 times 4 root 3, which is 64 root 3, and this does want us to leave it in simplest radical form, so I'm ending up with 64 root 3 square feet for number 72. Number 73 is a similar problem, although I don't have any of my sides here in my 45, 45, 90 triangle, but that's okay, we can find them. If this is 10, this is also 10, which makes this 6, because the entire piece down here is 16. In a 45, 45, 90 triangle, the legs are the same, so if this is 6, this is also 6, so we now have the height of our trapezoid. 1/2 times the height of 6, times the sum of the bases, which are 10 and 16. Half of 6 is 3. 10 plus 16 is 26. 26 times 3, 78 feet squared. Yep, that's it. That's what we're looking for. Okay. As I'm doing this, I'm working the problem and then I'm peeking over at the key to see if I've got it, to make sure I haven't made a mistake, because I want to make sure that you have everything correct on your review. Alright, 74 wants you to find the area of the rhombus. Area of the rhombus is 1/2 times diagonal 1 times diagonal 2. Alright, so if this is a 60-degree angle, then I'm going to be working a 30, 60, 90 triangle in here. If this piece is 9, then this piece is 9, because the diagonals are perpendicular bisectors of each other. Okay, so here I have my short leg. My long leg then is going to be the length of the other part of the diagonal here. So if the short leg is 9, then the long leg is 9 root 3. And since diagonals are perpendicular bisectors of each other, then this is also 9 root 3. So I have 1/2 times diagonal 1. Diagonal 1, 9 plus 9 is 18. And diagonal 2, 9 root 3 plus 9 root 3 is 18 root 3. Okay, half of 18 is 9, so I just have 9 times 18 root 3. So I just need to multiply then 9 times 18, which gives me 162 root 3. Notice this does ask for this in simplest radical form. So there you are in simplest radical form, and this is in units squared, because it is still area. Right, 75 is also a rhombus. Same process, 1/2 times diagonal 1 times diagonal 2. In this one, you have both diagonals that are 18. So I have 1/2 times 18 times 18. Half of 18 is 9, so I just need to do 9 times 18, which we just learned is 162. This one is in meters squared. Okay? Now the numbers will be different on the exam. And for those of you who are not exempt, I will tell you which problems, which of the 33 or which of the 95 problems are on the actual exams, which 33 of these problems. Alright, so looking now at 76, once you find the area of a regular hexagon. Okay, so finding the area of a regular hexagon, 1/2 times the perimeter of the base times the apothem, and it gives me everything I need here. If it's a regular hexagon, that's 6 sides, and if each side is 20, then the perimeter is 6 times 20, or 120, and it gives us the apothem. So all I need to do here is 1/2. Let me make sure you can't see what I'm doing, I'm sorry. Hexagon is 6 sides, each side is 20, so perimeter is 120, and it gives me the apothem. So I have 1/2 times the perimeter times the apothem. My perimeter, or half of my perimeter, half of 120 is 60, so all I need to do is 60 times 17.3, which gives me 1,038 miles squared. Area of my regular hexagon. There you go. If this problem is on the test, the numbers will be different, so please make sure you understand the process. Okay? And then 77 wants the area of a regular hexagon, and again they give you the side length. Okay? So you can use the same process here, 1/2 times the perimeter times the apothem. Side length here is 10, so your perimeter is 10 times 6, or 60. Okay, we just need the apothem. So if I'm looking at a regular polygon here, or regular hexagon, I know I've got a 30, 60, 90 triangle here. It tells me that the side lengths are 10. Because all these are 10. 10, 10, 10. Okay? I need that apothem though. That's what I'm sketching in right here. Okay? So if this is 5, and this is a 30, 60, 90 triangle, then that apothem is 5 root 3. 5 root 3. This one's your answer to the nearest tenth, so we're going to actually calculate it out. Half of 60 is 30. 30 times 5 is 150. So I have 150 root 3, but it wants me to calculate that out. So in my calculator, 150 root 3 gives me approximately 259.8, and this says meters squared. Checking. Correct. All right. Okay, so, oops, sorry. My screen went dark for a minute. Hope it didn't go dark for you guys. All right, so this says to find the measure of arc CDE. Arc CDE is this arc right here. Goes from C to E through D. So if you have such a situation or it names the arc something different, then just make sure that you're working with kind of a connect the dots situation here. Okay, so since DB is a diameter, and you know that because it goes through the center here, you know all of this is 180 degrees. And then you're just adding the 27 to it. So 180 plus 27 gives you 207, and they're just looking for a degree measure of the arc, so 207 is what we're looking for. Okay. Just recording a quick video here for the kids. Okay. Alright. So let's look at 79. We're wanting circumference here, 79 and 80 of these two circles. Circumference is pi times diameter, or 2 pi times the radius. We're given the diameter here in 79, so all we need to do is put a pi after it, because it says leave in terms of pi, so try not to overcomplicate this one. 5.7 pi is all you need, and circumference is a linear measurement, so we're just going to leave that in the units that they give us. For 18, they give us the radius, so we're going to use 2 pi times that radius. 2 pi times 18 gives us 36 pi, and again, in a linear unit, inches. 15 more. Alright. 81 wants the length of this arc, so here we are looking for a portion of the circumference. And what portion? Depends on what degree measure of the arc. Okay, so we want the length of ypx. So it's going to go through P, so we are looking at 3/4 of the circle here. 3/4 of the circumference, and it gives us a radius of 10, so our circumference is 2 pi times 10, and this does want us to leave it in terms of pi. Okay, so we have 3/4 of 20 pi, and I can reduce here because 4 goes into 20 5 times. 3 times 5 is 15, so I end up with just 15 pi meters. And a linear measurement there. And again, I know I'm going super fast just to try to keep this video as short as possible, but you have the freedom to pause, rewind, play it again, and make sure that you get everything down. Alright, 82 and 83 are both areas of circles. Okay, area of circle is pi times radius squared. For 82, I have a radius of 2.2, so I have pi times 2.2 squared. And this again, what's my answer in terms of pi? Circles generally make your life pretty easy. So hopefully you guys are finding this to be as easy as it can be. 4.84 pi, and it is area, so I'm going to be in square meters on this one. Correct? Alright, so on 83, notice they give you the diameter. So we first need to find the radius. The radius is half of that diameter, so if the diameter is 4.1, half of that is 2.05. So I have pi times 2.05 squared, which gives me 4.2025 pi meters squared, and it actually wants all those numbers in the answer. Okay, so make sure that you're understanding the process because the numbers will be different on the exam. Alright, 84 wants the area of a sector with a central angle of 170 degrees and a diameter of 9.1. A sector is a portion of the area, a fraction of the area. The fraction is whatever the degree measure is out of 360. Okay, so we have 170 degrees out of 360. That's the fraction of the whole circle we're looking for, times the area, which is pi times the radius squared. They give us the diameter of 9.1, so we're going to divide that by 2 to get our radius. Radius equals 4.55. So we have 4.55 squared. It wants us to round to the nearest tenth, so we are going to calculate all of this out. 170 divided by 360 gives us approximately 0.472, and that 2 is repeating. And then I have 4.55 squared with a pi after it. 4.55 squared times pi, which is approximately 65.04, and I'm multiplying that times by 0.472, which gives me a final answer here of approximately 30.7, which is correct. centimeters squared. Alright, so that ends Chapter 10. All we have is 10 problems in Chapter 11 and we're done. Chapter 11 was surface area and volume. So on 85, this gives you a box, gives you a rectangular prism, and it wants the lateral area and surface area. The lateral area is just the sides, so no bases. Front and the back, and the left and the right. Okay, and you have 4 rectangles here, 2 that are 1.66 by 14, and you have 2 that are 1.66, which you can see what I'm doing, times 7. Okay, so this is just calculations. 1.66 times 14, that's the front. Multiplying that times 2 because there's also a back. 46.48 plus, then I'm looking at the left and the right. That's 1.66 by 7. 11.62, and there's 2 of them because there's a left and a right. So 23.24 is getting added to that. 46.48. Alright, so our lateral area, which is our wraparound, just the sides, is 69.72 centimeters squared. Okay? And we also need the surface area. Our surface area just adds the top and bottom. So we have that's our lateral area plus the top and the bottom. The top and the bottom are 14 by 7 rectangles. Okay? So 14 times 7. 98 for an area of the bottom, and we're going to double that because there's also a top. So I have my lateral area, which is 69.72, and I'm adding to that 196. And I'm getting a surface area of 265.72 centimeters squared. Lateral area, surface area. And I will validate these answers before we put the exam out, make sure that everything's good. Now I am recognizing here that this is asking you to round to the nearest whole number, so the lateral area will actually be approximately 70 and the surface area will be approximately 266. Hopefully you would recognize that on the actual test because the decimal answers wouldn't be options. Alright, so looking at 86. We have 86 and 87 surface area of cylinders. Surface area is just the area of the surfaces that you can touch. Okay, so for the surface area of cylinders, we have the top and the bottom, which are both circles. So we have 2 times pi r squared. That takes care of our top and our bottom. And then we have wraparound. This is like a soup can label. When you peel off that soup can label, the length of that rectangle is the circumference of the circular top and bottom. Okay, so we have circumference, 2 pi times r. And then the height of that rectangle is the height of the can. So, all of our information is given to us here. They give us a diameter of 9, which means our radius is 4.5. So I have 2 pi times 4.5 squared plus 2 pi times 4.5 times the height of 19. Alright, so this is just calculations. Now fortunately it does want this in terms of pi, so we don't have to calculate it completely. Alright, so I end up with 40.5 pi here. And then for the label, 4.5 times 19 times 2 gives me 171 pi. So I'm adding 40.5 pi's to 171 pi's. And that gives me 211.5 pi's. This is area, so we are in square units. 211.5 pi, good. Alright. 87, exact same thing, except they actually give you the radius here. So 2 pi times your radius of 9 squared plus 2 pi times your radius of 9 times your height of 20. So 9 squared is 81. 81 times 2 is 162 pi plus. And then on the other side here, 2 times 9 is 18. 18 times 20 is 360 pi. And then you're just adding 360 plus 162. Alright, that gives you 3, 4, 5, 22 pi. Yes. Okay, so we end up with 522 pi inches squared for that one. Okay. It's a little bit messy, so you may want to go back and actually listen to what I'm saying and not just try to copy down what's being written, because it's actually important that you understand how to do these. Alright, one more surface area of a cylinder, and this one wants it to the nearest whole number, so we are actually going to be computing pi in this one. But the formula is the same. 2 pi times the radius of 15 squared plus 2 pi times the radius of 15 times the height of 19. If you're thinking that these problems look familiar, it's because they should. You've seen all of these on tests. So here I have 450 pi's. plus 15 times 19 times 2, 570 pies. Excuse me, a total of 1020 pies. And this time I am going to multiply that 1020 times pi to get my final answer here. It wants it to the nearest whole number, so it's approximately 3,204 inches squared. Please make sure that you are understanding how to work towards these things, and that you can work towards these things without just copying it from the video, since you are going to actually have to be able to do these on your own if you have to take the final. Alright, 6 more. 89 wants, it says the radius of the base of a cylinder is 38 and the height is 51, and it wants the surface area. So you can sketch out a cylinder if you'd like. It's kind of fun, a little bit of challenge. Okay. It says the radius is 38 millimeters. And the height is 51 millimeters. So now we're looking at the exact kind of problem we looked at in number 88. Okay, surface area, 2 pi times 38 squared plus 2 pi times 38 times 51. Alright, so we're just calculating here, but it does want us to leave it in terms of pi, so we don't have to go all that far. 38 squared times 2, 28, 88 pi. It's a lot of pies. 38 times 51 times 2. 38, 76 pies. So we're adding our 38, 76 pies to our 28, 88 pies. And we are getting 6,764 pies, millimeters squared. Checking. Correct. Alright. Last page. The volume of the given prism. Okay? The volume of any prism, no matter what the shape is just the area of the base times the height of the prism. So for a box, for a rectangular prism, you're just multiplying the 3 dimensions together. So I'm going to do that. 13.2 times 3.9 times 6. 13.2 times 3.9 times 6. Nearest tenth, 308.9. This is approximate centimeters cubed. Remember that when you're working in volume, you're in cubic units. Okay? 91 wants the volume of a square pyramid and gives you base edges and a slant height. A pyramid is a third of the associated prism, so we are going to use the same concept of area of the base times the height, but we're going to take a third of that ultimately. So this is 1/3 times the area of the base times the height of the pyramid. Okay? So this gives us base edges of 48. This is a square base. And it gives us the slant height. The slant height is the height of that triangular side. Okay, it gives you the slant height of 26. Now that slant height isn't exactly what we need here. What we need is the height of the actual pyramid. So we are going to drop a height down inside that pyramid and draw in an apothem of the square. And we are going to work that floating triangle to find the height. So half of 48 is 24. So we're looking at a leg of that right triangle is 24 and the hypotenuse is 26. Hopefully you're recognizing the triple. Both of those are divisible by 2. 26 is 2 times 13, and 24 is 2 times 12. So you have a 5, 12, 13 here. So the height must be 2 times 5, or 10. We've seen this exact problem before also. So the height of this pyramid is 10, and the base edges is 48. So 1/3 times the area of the base, which will be 48 times 48, times the height of 10. Now it's just a matter of calculating. 48 squared times 10 divided by 30. Okay? So we end up with 7,680 centimeters cubed, because it's volume. Correct. Alright, 4 more. 2 of these are surface area of spheres, and 2 are volume of spheres. Okay? Surface area of sphere is 4 pi r squared. Okay? So they give us the radius here. 4 pi times the radius of 60 squared. And this does want your answer in terms of pi. So 60 squared times 4 gives us 14,400 pi meters squared. That exact problem, I believe, was on the last test. I think this one was too. So if the diameter is 14 and the radius is 7, 4 pi times 7 squared, or 4 pi times 49. 4 times 49 gives us 196 pi centimeters squared. Alright, So the last two here are volume of a sphere. Volume of a sphere is 4/3 pi times the radius cubed. Okay? So we're given the radius in both of these, or the means to find it. The radius in 94 is 9, and the diameter in 95 is 14, so the radius here is 7. So we're just plug and play. Now this does want it to the nearest cubic unit, so we are going to calculate the whole thing and then round. 4/3 pi times your radius of 9 cubed. Okay? Now, just to save some time, if I'm calculating here, I'm going to go ahead and draw out or write out the 9 cubed as 9 times 9 times 9. That's not what I wrote, is it? Thanks for catching that. Alright, so 3 goes into one of the 9s 3 times. And now we have a little bit less calculation to do. 9 squared is 81. 4 times 3 is 12. So I have 81 times 12 pi. Now you could just punch all this in together and not go through the reduction process like I just did. But just be really careful and make sure that you're putting parentheses where they need to go, or do it in pieces. That's fine too. Alright, so the nearest cubic unit gives us approximately 3,054 millimeters cubed. Correct. Alright, one more. Same exact process here. I've got 4/3 pi times my radius is 7 cubed. Nothing to reduce here. May as well just start calculating. 7 times 7 times 7 times 4. So that gives me 1372 pi on top, all divided by 30. So multiplying that times pi, and then dividing that by 3, and rounding to the nearest whole number, which is 1,437 cubic centimeters. And that's it. I will post which 33 of these 95 problems are on the exam, probably in the next couple of days. For those of you who are not exempt, we are telling exemptions tomorrow and Friday. So you will know that. But this is a big extra credit grade if you will finish this review. So please make sure that you are taking your time with this and get that turned in on or before the 26th. Thank y'all.